we're going to do lesson 9.5, solving quadratic equations using the quadratic formula. So this is the fourth way that you can solve a quadratic equation. Again, as a review, you can graph, you can use square roots, you can complete the square, and then after today, you will know how to use the quadratic formula. Now, the essential question says, how can you derive a formula that can be used to write the solutions of any quadratic equation in standard form? I want you to grab your highlighters and I want you to highlight standard form. Now, you've learned two standard forms with me. One is the standard form of a linear equation, which you learned before I went out on maternity leave. All right, does anybody remember the standard form of a linear equation? AX plus BY equals C. That's the standard form of a linear equation. What is the standard form of a quadratic equation? AX squared plus BX plus C. So I want everyone underneath standard form in the essential question, I want you to actually write the standard form. AX squared plus BX plus C. Because without this form in your memory, you will not be able to identify A, B, and C, and you will not be able to work our problems today. Now, the first thing we're going to look at is something called the discriminant. So we're not to the quadratic formula yet, but in order to do the quadratic formula, we've got to start by working with the discriminant. Now, what does the discriminant tell us? When finding the solutions to the discriminant, you are finding the number of x-intercepts. So I want you to highlight where it says number of x-intercepts. You're not actually finding the x-intercepts. You're finding out how many x-intercepts the problem will have. So that's important. Because if your discriminant, and your discriminant is the formula b squared minus 4ac, if it comes out to be a positive value, you are going to have two solutions. And I want you to put a slash next to solutions, and I want you to put x-intercept. Because solutions and x-intercepts are interchangeable. Okay? If the value of your discriminant is positive, you have two solutions, two x-intercepts. If the value of your discriminant is 0, you have one solution or one x-intercept. Again, solution and x-intercepts are interchangeable. If the value of your discriminant is negative, you have no solutions. All right? Slash x-intercepts. You would have no x-intercepts. Now, before we move on to a problem, I want you to highlight the actual discriminant formula. It's b squared minus 4ac. Now, let's talk about the 4ac. If you look at the 4 and the a, and then the a and the c, there's nothing separating the 4 and the a or the a and the c. So what operation are we dealing with right here? Multiplication. So we've got b squared minus 4 times a times c. Now, in example 1, pay attention to what they're asking you to find. It says determine the number of real solutions of the equation. So are they asking us to actually find the solutions? No. So I want you again to take your highlighter and highlight number of real solutions. Because at this point, if you see this on a quiz or a test or a homework, you have to know, how do I find the number of real solutions? This is where you're going to use the discriminant. So looking at letter A, we have 6x squared plus 2x equals -1. Now we know we need an a value, a b value, and a c value. Is this problem set up in the correct form for us to identify a, b, and c? No. Why not?
There's no c.
Okay, well there's a c, but it's not on the right side of the equation. Everything has to be on one side, and it has to be set equal to 0. So what do I need to move in order to make that happen? -1, and how do I move it? I'm going to add it to both sides. Now, the +1 that we just added to the left side, does it combine with anything that's already over there? No, so we have to bring down the right terms in the right order. This is key to getting this right. So 6x squared plus 2x plus 1. That's standard form, that's descending order. And it equals, what's -1 plus 1? 0. Now normally I don't have to bring zeros down, but when it's the only thing left on that side, I do have to. Okay? Now can we identify A, B, and C? Yes. What does my A equal? 6. The coefficient of x squared is a. B equals 2. The coefficient of x is b. And what is my c?
1.
My constant is my c, and that is 1. Now, let's write down the discriminant formula. Yes, you need to write it down. The more we write it down, the quicker we'll memorize it. So b squared minus 4ac. Now, everything's going in parentheses. So what is my b value? 2 squared minus 4 times, what's my a? 6. Everyone, what's my c? 1. Now, order of operations matters here. Please excuse my dear Aunt Sally. Am I supposed to do the exponents, the subtracting, or the multiplying first? Exponent. So 2 squared equals 4. Now, I'm going to go ahead and bring down that minus sign so I can just focus on multiplying the numbers. What's 4 times 6? Times 1. 24. And last but not least, what's 4 minus 24? Negative 20. Now, box that in because that is the value of your discriminant. Now, based on that value, what is the number of real solutions?
1.
It's negative, so there are no solutions. And we're using the word solutions instead of x-intercepts because of the directions. The directions say find the number of real solutions. So there are no solutions for this first one. This graph would not touch the x-axis at all. Now look at letter B. Is this one set up for us to identify A, B, and C? No. And typically, what would be the easiest move here? Move the 1/2 x squared. However, we've worked really hard. We really don't like or want, for a lot of problems, a negative leading coefficient. So let's just keep that going, and let's leave the 1/2 x squared where it's at so we have a positive. I'm not saying you couldn't work with a negative a value, but there's a lot of problems where you can't have a negative leading coefficient. So let's just keep this positive, which means we're going to move what? The 7x and we're going to break the rules and we're going to move both of them at the same time. How do I move 7x to the other side? Subtract it. And how do I move the negative 1? Add it. Now on the left, am I able to combine any of those? No. So the order we bring it down matters though. What comes down first? 1/2 x squared, then minus 7x, then plus 1. And of course it equals 0 because all that stuff on the right canceled out. Now can I identify A, B, and C? Yes. What's my A? What's my B? Negative 7. And what's my C? 1. All right, let's write down the discriminant formula. What is it? B, the formula. B squared minus 4AC. All right, what's my B? Negative 7. Now, it's really important that you plug that in parentheses. And if you're using your calculator, you've got to plug the negative in parentheses before you square it, or it will give you negative 49. Okay, you have to put it in parentheses. Minus 4 times A. What's my A? 1/2. And my C? 1. All right. What is negative 7 squared? Positive 49. Remember, every time we square a number, we get a positive answer. Bring down that minus sign. What is 4 times 1/2? 2. And 2 times 1? 2. What's 49 minus 2? Box that in. That's your value. Now, based on my value, how many real solutions would this graph have? 2 solutions. Again, that means this graph would cross the x-axis twice. Now, moving on to example number 2. The directions say find the number of x-intercepts of the graph of the function. So again, you've got to pay attention to the directions. Are they asking us to find the x-intercepts? No. They're asking us to find what? The number of x-intercepts. So once again, I want you to highlight that. Now, what are we going to use in order to find the number of x-intercepts? We're going to use the discriminant again. And here's what I need you to understand. Example 1 and example 2 are asking you to do the exact same thing. They're just using different words. Correct? Do you agree with that? Yes. Example 1 said find the number of real solutions. Example 2 says find the number of x-intercepts. Solutions and x-intercepts are the same thing. So you've got to pay attention to the directions. If it's asking you for the number of real solutions or the number of x-intercepts, you have to use the discriminant. Now, let's look at letter A because it does look a little different than what we just did. There's an f of x right there, and we learned a long time ago that f of x can be replaced with what variable? Y. All right? And we also learned a long time ago, if we're ever looking for x-intercepts, what does y need to equal? If we want the x-intercepts, y has to equal what? 0. So this is why we change the y to a 0. And we have 0 equals x squared plus 12x plus 36. This is why we can just randomly change our y to a 0. Because we're essentially looking for x-intercepts. But we're not actually going that far. Right now we're just trying to find the number of x-intercepts. So, can we identify A, B, and C?
Yes.
What does A equal? 1. What does B equal?
12.
And what does C equal?
36.
Good. What is the discriminant formula?
B squared minus 4AC.
B squared minus 4AC. What's my B value? 12 squared minus 4 times A? 1 times C? 36. All right. We do what first? Exponent. What's 12 squared? All right. Bring down the minus sign. What is 4 times 1 times 36? 144. What is 144 minus 144? 0. Box in that value. Since the value of the discriminant is 0, how many x-intercepts would this graph have? 1 x-intercept. So look, we're changing it from solution to x-intercept simply based on the directions. So because of this discriminant value, we know that there would be 1 x-intercept. Now look at letter B. We need to change the y to a what to start? To a 0. So 0 equals negative x squared plus x minus 6. Are we able to identify A, B, and C? A equals negative 1. B equals positive 1. And C equals negative 6. All right. Give me the discriminant. B squared minus 4AC. What is B squared? 1 squared minus 4 times A and C. Now, I want to show you something. First of all, let's do our exponent. What's 1 squared? 1. Up to this point, we kept bringing down the minus sign because it was the only negative sign in the problem. But I want to show you something. There's 2 ways you can get to this answer right here. All right? I can either do my multiplication. So let's do the multiplication. What's negative 4 times negative 1? Because essentially this is a negative 4. Every number has a sign. The sign's directly in front of it. So again, what's negative 4 times negative 1? Positive 4. And what's positive 4 times negative 6? Negative 24. However, let's say when you multiply, you don't want to have to think about negatives and positives. All right, I can help you with that. Count the number of negative signs in this problem, including the minus sign. So we got 1, 2, 3. Is that an even amount or an odd amount of negative signs? If your number of negative signs is odd, then you can automatically know that your final number will be negative. If there is an even amount of negative signs, then you know what would be your final sign. Positive, because a negative times a negative is a positive. Okay? Again, that's just a shortcut if you don't want to have to multiply and think about negative numbers. Once I figured out my sign, now I can just focus on 4 times 1 times 6. And what is 4 times 1 times 6? 24, not negative 24. We already took care of finding out what the sign was going to be. Okay, that's what I'm saying. If you count the number of negative signs and realize it's odd, you can go ahead and put down the negative or the minus and just focus on 4 times 1 times 6. And that's 24. What is 1 minus 24? Negative 23. So there's my value of the discriminant, which tells us what about the number of x-intercepts? No x-intercepts. And that would be the second answer that I box in. Now, are there any questions about the discriminant? Again, the discriminant only helps me find the number of solutions. That brings me to my quadratic formula. And you can see in all caps, I've said memorize. Here's why. This formula is not going anywhere. I was talking to a former student earlier today. She's in geometry. She is using algebra in geometry. She even said she was using this formula. So this formula is not going anywhere. You need to commit it to memory. But look at it. It says x equals, again, why x equals? Because we're looking for x-intercepts. Negative b plus or minus the square root of, what do you see right there under the radical? The discriminant. So the biggest part of this formula is the discriminant that we just used in 4 problems. But this time it's under a radical. So the square root of b squared minus 4ac, all divided by 2a. Take your highlighter and highlight it. You have got to know this formula. It may very well be a test question or a quiz question. All right? Now, in example 3, it says solve the equation using the quadratic formula and round your solutions to the nearest tenth if necessary. If we round to the nearest tenth, that's how many decimal places? 1 decimal place. Okay? Now, you've got the flow chart on your notes. Go ahead and fill in the first box on the left. It's letter A. X squared minus 6x plus 5 equals 0. Now, the first step is to make sure that it's in the right form. Is everything on one side set equal to 0? Yes or no? Yes. So, we're going to follow the yes arrow, and we're going to go to step number 2. It says find the values, and we've been doing this all hour. What is the value of A? 1. What's the value of B? What's the value of C? 5. Follow the arrow to step 3. We're going to plug it in, and they've given you the formula. So x equals a negative, what's our B value? Negative 6. Now listen, there's a negative sign in the formula. It does not replace the negative sign in front of 6. You have to plug in the negative 6. Plus or minus, again, what's your B value? Negative 6 again. Minus 4 times A and C. Divided by 2 times A. 1. Now, step number 4 is where we tidy up. All right, here's what we're tidying up. Number 1, are there double negatives at the beginning of your problem? Yes, so that double negative becomes what? A positive 6. So we have x equals positive 6 now. Plus or minus, we're supposed to calculate the discriminant. So let's calculate. What is negative 6 squared? 36. Minus, I'm going to bring down that minus sign. What is 4 times 1 times 5? We already brought the minus sign down. So it's 20. Okay? Make sure the radical goes over the entire discriminant. And then it is divided by 2 times what? 2 times 1. Well, what is 2 times 1? 2. All right? So we've tidied up the third thing. We simplified the denominator. Now we're supposed to rewrite our equation. So x equals 6 plus or minus the square root of, what's 36 minus 20? 16. And all of that is divided by 2. Okay, so you might have to write a little bit smaller in step 4. But that leads us to step number 5, where we simplify the root. Now, it could be a perfect square. If not, that's okay, because we already know we're going to round to the nearest tenth. So x equals 6 plus or minus, what is the square root of 16? 4 divided by 2. And that leads us to step number 6, where we're supposed to do the plus minus. So what's the first equation we're going to solve in step 6?
6 minus 4 over 2.
All right, you want to do minus first. 6 minus 4 divided by 2. And what's the second equation?
Equals 6.
Someone other than Connor. He did 6 minus 4 divided by 2. What's the second equation? 6 plus 4 divided by 2. All right. What is 6 minus 4 divided by 2? It's 2 over 2, which equals 1. And what is 6 plus 4? 10 divided by 2 gives us the final answer of 5. So your graph would cross the x-axis at 1 and at 5. Let's look at letter B. Go ahead in the second box of step 1, the second flow chart, and put 4x squared minus 4x equals negative 1. Now, is this one in the correct form? No. So what do we have to do to get it in the correct form? Add the 1. So we got to follow the no arrow this time, and we're going to add 1 to both sides. So 4x squared minus 4x plus 1 equals 0. Now can we identify A, B, and C? Yeah, what's A? What's B? And what's C? There you go. Step 3, plug it in. X equals negative, what are we plugging in? Plus or minus, what are we plugging in? Everyone, minus 4 times, what's A? A is 4, and C is divided by 2 times, what's A again? 4. All right, tidy up. Do we have any double negatives? Yeah, we got a negative 4, or the opposite of negative 4, which equals what? Positive 4. Plus or minus, what's negative 4 squared? Under the radical, what's negative 4 squared? 16. All right, minus, what's 4 times 1? 16, all divided by 8. What is 16 minus 16? So really we have 4 plus or minus the square root of 0 over 8. Now, what's the square root of 0? Nothing. Okay, 0. It's 0. But also, we learned this earlier. If the discriminant comes out to be a 0, how many solutions are you going to have? Just one. So we have x equals 4/8. And we can carry that over into step 6. X equals 4/8 because we only have one problem to work. And what does that make our final answer? 1/2. But we knew all the way over here in step number 4 that we were only going to have one answer. So this graph would only cross the x-axis at 1/2. Now, in example number 4, it says solve the equation using any method. So this is where you have a choice. But let's talk through our choices and let's pick the best choice. First of all, looking at letter A, could we graph to solve this equation? Yes or no? Yes, graphing always works. All right. The only problem is right now we don't have Desmos in front of us. So really graphing isn't the most convenient. Let's talk about square roots. That's the second method you learned. Can you use square roots to solve this problem?
No.
Why can't I use square roots on this one? There's an x term. Very good. So square roots is out. Could I complete the square? Yeah. Would it be super simple? I mean, for some of you, you've got to move the 12. The leading coefficient is already a 1. So if you wanted to complete the square on this one, if you're comfortable with completing the square, it would work, and it would work pretty easily. All right. What about the quadratic formula? Can I use the quadratic formula? Yes, that one again always works. So because it's our new method and I want to practice it without a flowchart, we're going to actually work this with the quadratic formula. But I want you to see graphing is an option, completing the square is an option, and quadratic formula is an option. Can I go ahead and identify A, B, and C? Yes, I can. So A equals, B equals, and C equals. Good. Let's write out the formula. X equals negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. Remember, we're using the quadratic formula because we're trying to solve it this time. We want the actual intercepts. Now let's plug in our values. X equals the opposite of, what is our B value? 11 plus or minus, what's our B value again? 11 squared minus 4 times A and C. Negative 12. Now again, make sure the radical goes over the entire discriminant. And then of course this is all divided by 2 times A. What's our A? 1. All right, let's tidy up. Do we have any double negatives? So what are we bringing down right here? Negative 11 plus or minus, what is 11 squared? 121. Now looking at our negative signs, we got 1, 2. So will our final sign be plus or minus? That's a positive. Now we can just do 4 times 1 times 12 because we already figured out the sign. What is 4 times 1 times 12? 48. And divided by? The denominator is 2. All right, let's keep going. We have x equals negative 11 plus or minus. What is the square root of 121 plus 48? 169 divided by 2. Can we simplify that radical anymore? Yes. What is the square root of 169? 13 divided by 2. Now, how many equations do we have to write and solve? 2. All right, you guys keep working down. I'm going to come up here to the side because I ran out of room. But what is the first equation that we're going to solve? X equals negative 11 plus 13 divided by 2. And x equals negative 11 minus 13 divided by 2. What is negative 11 plus 13? 2, and 2 divided by 2 equals 1. There's my first answer. What's negative 11 minus 13? Negative 24 divided by 2. What does x equal? Negative 12. So this graph would cross the x-axis at 1 and at negative 12. And again, if we go back here to what we got under the radical, it was a positive number. So we should know at the end we'll have 2 answers. Now let's look at letter B. Again, let's talk about our methods. Graphing. Could we graph this problem? Yes. Yeah, graphing always works. Can we do square roots? Yes. Why can we do square roots this time?
No.
There's no x term. I don't think y'all will ever forget that after all we went through to get there. Okay? There is no x term. So square roots is probably our quickest and best bet. But let me ask you this. Could we complete the square?
Yes.
You don't have an x term, which would make the coefficient of x a what? What number represents nothing? 0. So really we could put 9x squared plus 0x minus 5 equals 4. But why would we go to all that trouble? Could we do the quadratic equation? Yeah, again, a would be 9, b would be 0, and then c would be a negative 9 once we move the 4 over. But again, why go to all that trouble? Let's go back to square roots. It's the quickest and best method. Now, what do I have to do first? I have to isolate the x squared, so I have to add the 5. So 9x squared equals, what's 4 plus 5? 9. Am I ready to get rid of x squared? No, x squared still isn't isolated. How do I isolate x squared? Divide both sides by 9, so x squared equals, now can I get rid of the x squared? How? Square root both sides. Now, I put the radical into the problem. What else do I have to put into the problem? That plus or minus. So what is the square root of x squared? And it equals plus or minus. What's the square root of 1? So this graph would cross the x-axis at a positive 1 and a negative 1. And that is lesson 9.5.